Alright, the next topic we're going to talk about is inheritance. And inheritance is very, very important in object-oriented programming. And to really introduce this concept, I'm going to basically go into an application where we're going to model a checkings account and savings account. So, to do this, though, the first thing I want to do is I want to basically first create a class account. So I have a class account right here, and so this is basically going to represent a general version of how an account works. So now, because we're defining a new class, we can practice our object-oriented ideas. So what's something that every single account has in common? It always has an interest rate. So I'm going to call it an interest rate of, let's say, 2%. All right. Now, then we need to construct an account each time. So really, what's the only thing I need to worry about when constructing an account? I'm just going to worry about the name. So I'm going to bind self.name, an attribute to the name, and also what's something that every specific account has to keep track of, and it's very specific to an account. Well, obviously the balance. So I'm going to make an instance attribute of the balance. So it's important to have some representation of the balance. And so this is going to be very similar to our non-local example we did with make a balance. So we're going to have what's something a bank account should be able to do? Well, it should be able to deposit. So if we deposit something, so let's say we deposit an amount, what it should basically do is it should just increment the amount, the balance by whatever amount we pass in. And then also, whenever I do some deposit, I want to have some type of summary of what I did. So I'm going to actually define another method that's going to be a summary. And what this is going to do is I'm going to do the following. I'm going to return a string. So your balance, I want to say your balance is some amount of money, dollars. Okay? So how do I represent that some amount of money? I want to have, so what's my money? My self.balance. But I can't just put self.balance in here. I can't do this. That doesn't make any sense because it's going to show self.balance. So how do I do this? Well, there's a little handy syntax where you can basically put a representation of what you want to put, and then you can do .format, which is a string method, and then we can just put self.balance, and it will automatically format this integer into the string wherever we indicated that it should go. So this is a very useful method sometimes, so it's good to know. And then of course we want to return. So so we want to basically return the summary. So should we just call summary like this? Is that what we should do? And the answer is actually no, because this again goes into the important distinction between functions and methods. This is not a function, this is a method. And methods are always tied to objects. So what's the object right now? It's self. So we should return self.summary. Okay. And then the last thing we have to do is we have to also have some way to withdraw money. So when we withdraw some amount of money, we are always going to have the balance, okay? And we should also check if it's the case that the self.balance is less than the amount. Oops. We should return that we don't have enough funds. Okay, insufficient. Okay. And now, otherwise, we know we can decrement the account. So self.balance is equal to self.balance minus amount withdrawn, basically. And then we return the summary of the account. So self.summary of what we did, basically. So now let's see how this works. So this is, again, good practice with how to define an object-oriented program. And there are many ways you can define it. See, one thing about whenever you do object-oriented design that you might like more than our normal functions is there's not necessarily such a strict interpretation of how an account should work. You could have had some more methods that could have done some other things. So there's a lot of freedom with object-oriented programming. It's very easy to add or remove things, which is why object-oriented programming is so great. But anyway, let's see how this class works. So I need to first define an account. So I'm just going to make an account under my name. And so this account is initially going to have a balance of 0, as it should. And then I'm going to deposit some amount of money. So let's say I deposit $100. Oh, I should pass in self here. I knew I made a mistake somewhere. I felt like I made a mistake. This was just going too smoothly for me not to make a mistake. Okay, so there we go. There we go. Your balance is $100. Okay, so now I have $100, and then if I withdraw some amount, my balance is $50. And then if I withdraw more than I have left, let's see what happens. I get insufficient funds. So that's basically the functionality of this account class. So it's very basic, but it's for now a good representation of what a bank account should be able to do. Okay, so now, what was our original purpose? I spent quite a bit of time defining an account class, but why did I do that? Because at the end of the day, a checking account and a savings account are just special cases of an account. So because of this, using this, I can do something very amazing in object-oriented programming called inheritance. Okay, so what I'm going to do is I'm going to define a checking account. Okay, and the big thing here is maybe I can just copy and paste this because I basically need to use the same functionality. A checking account should still be able to give a summary, a deposit, and a withdrawal, right? Because it's still an account. But the beautiful thing with inheritance is I can actually inherit from this class all of these properties and methods. So with this powerful statement, literally just put parentheses and an account, I have now inherited all the methods and all the attributes from this class. And this class right now is called the base class, and this is called a superclass. And I'll talk a little bit more about that terminology. Sorry, this is not called a superclass, this is called a subclass. I misspoke there. So this is called a base class, and this is called a subclass. Alright, so now, what I can do with this checking account is I can actually use it just like this. So even if I did nothing right now, I don't have to do anything. The beautiful thing is I can use a checking account. So it's going to basically be the same as my account. What's going on? 954. Oh, I think I probably had to put something in here. Okay, so let's say I have an interest. So, okay. So one thing I'm going to define in this checking account that's going to be a little different is it's going to have, the checking account is going to have a withdrawal fee. Withdrawal fee is included in the checking account. Okay. And then, so basically what I'm going to do is I'm going to do a withdrawal fee. And I'm going to make this a class attribute because it's something that every single checking account should have. So I'm going to make a withdrawal fee of $1. So now let's try this again. And now what I can do is earlier I had an account for Nipun, and then now I also have a checking account. And I can actually use a constructor from the checking account. And even though I didn't define a constructor, it's going to automatically use this constructor right here. So it's going to use this constructor right here, even though I didn't define the constructor here. So this is the beauty of inheritance. It inherits the constructor as well. So now, if I check what my balance is for my checking account, I get 0. But now if I want to deposit, I can now deposit into this checking account, just like before. So if I deposit $10, I get my balance is $10. And this all works because I've inherited all of this from the account. So I defined one class initially, but now I have two classes with just an extra statement and inheritance. So that's the beauty of this. Now, obviously, the checking account is going to act a little differently because we now have a withdrawal fee. So what I'm going to do is I'm going to modify my withdraw function. Okay? Sorry, not my function, my method. And it's going to take in self, and it's going to take in an amount, just like this function. But now this one is going to be a little different, slight difference, because of fee. Okay? So we have a fee now. But at the end of the day, we know that this withdrawal function is going to be the same as this withdrawal function, except for that fee. So how can we use this function within this function? Well, one thing we can do is we can do self.withdraw, because what is self refer to? Self is an object within the checking account class. So if we do self.withdraw of something, it's going to call this withdraw method, and that's not going to get us anywhere. So this is not one of the situations where we can do recursion on this, so that's not going to get us anywhere. So somehow we need to find a way to get this withdraw method. So how do we do that? Well, if we can't use self, the only other option that we can have is, as earlier I talked about, we can access the method through the class. So I'm going to do exactly that. So this is one of the cases where you do want to access the method using the class. So account.withdraw, okay, and so now because I accessed it through the class, I have to pass in a self. What's my self? Well, a little confusing, but the self that we have here is going to be bound to the self that we have here. So it's a little confusing, but basically what this means is this is going to be a checking account object. So we want to modify the checking account object, so we're going to use this self. Okay, and then we're going to what's our amount? So it's going to be whatever amount we have. And then we're also going to have to include the fact that we're going to have to withdraw a little more for paying the fee. So we're going to take the self.withdrawal fee also. And so let's see how this works. So I have my normal account, and I have my checking account. My checking balance is initially 0. So now I'm going to deposit 10. Depositing is fine because I'm just using this deposit. But now what's going to be different is I'm going to withdraw a little differently. So if I withdraw $5 in the account version, I would have $5 left in my balance. But now I'm only going to have $4 because I have that checking fee. So let's check that out. So your balance is now $4 because I have that fee. And this is the subtle difference between this checking account class versus this base class, which was an account. So this is a huge idea. So even though I inherited all these methods, I basically overrode the withdraw method in the checking account. I changed it to modify how a checking account should act, and I defined it arbitrarily as it should have a withdrawal fee. So whatever way you want to make the checking account different, you can. But the great thing is, with inheritance, you don't have to make only minimal changes rather than rewriting the entire class from scratch. So this is a big idea of inheritance.